Hello everyone. In the past lesson we covered the various types of ensemble methods ranging from decision trees to random forest to adder boost and all the way to XGBoost. Now before we move away from ensembles altogether, this is the last part that I do want to actually cover with you, which is the ensemble of ensembles, also called model staking. Now, ensembles with different types of classifiers. There's also ensemble with single type of classifiers. Different types of classifiers mean you're combining them all together. Ensemble with a single type meaning you're only drawing from one sample or one type of classifier alone. Now, let's start with the first one, ensemble with different types of classifier. There are obviously different types of classifiers you can use. You can use logistic regression, decision trees, random forests, etc. Now, they are all fitted on the same training data. The results are then combined either based on either majority voting, that will be your classification, or averaging them. There will be. And then the ensemble with a single type of classifier, there's a typo here. This is bootstrapping samples are drawn from training data. Now with each bootstrap sample, separate models will be fitted. It could be decision trees, it could be random forests. Now all the results are combined to create an ensemble. Now this is suitable for highly flexible models that is prone to overfitting as well as high variance. Now, just to highlight this before we move on, is the fact that with the single type of classifier, it's only one model that will be used. The one model could be decision tree or random forest, meaning just using one for the whole ensemble. We're going to show you an example on that. Then you have the combining method, which I briefly touched on earlier. If it's classifier, it could be based on votes, or it could be average if it's a regression. The method or application of the meta classifier on the outcomes, and also the method application of meta classifier on probabilities. So you have these three different ways of combining the actual outcome itself. The meta classifier meaning is actually applied on top of the individual classifier. So it could be logistic regression on top of another layer, the base layer of your predictors or your classifier. And the last one is the probabilities are obtained from individual classifier, and then you apply a meta classifier on top of that. Okay, so let's look at the actual model itself. Hopefully this looks somewhat familiar because this is what we actually did use all along, which is the HR database or the data sets earlier. Now the next thing that we're going to do is do the train test split, which we've already done earlier, so let's do that. And we also want to import the functions that we've written before. Okay. Right. Okay, so basically we've prepped all the stuff that we need to do. What we want to do now is let's start with some of the combining the classifier. For the sake of the exercise, we're going to combine two classifiers. I guess let's start with decision tree. So there will be our first one. So we use model 1 and we call this decision tree. Okay, so let's just do that. All right, import the decision tree classifier and we call this tree classifier. Tree classifier is the decision tree classifier. Okay, so let's just leave that as it is, and then we tree classifier, and we're gonna fit that to our X train and also Y train. Okay, having done that, right, the next thing now is just print our performance. Gonna do it twice, and we're gonna use the tree classifier. Once is in sample, once is out of sample. Okay, let's just print that. Okay, all right. Having got that basics, what is the second model that we want to do? Let's just do a simple one. Decision random forest. It's been pretty good to us, so let's just use that. Okay, model 2 random forest. Okay, let's import the random forest. Okay, import random forest classifier. And random forest classifier is good to random. Okay, and then random forest classifier, we're gonna fit X train and Y train. All right. Okay, you want this to be revel. That's fine. Okay. Right. So let's print the fitting result. Okay. Now that we've done that too, right, let's use I think what we use is that we combine all of these. So we actually have two models here. So let's look at combining them. So we call this combine. Let's call ensemble of ensemble. Okay, ensemble of ensemble. Okay, and we're just going to create an empty data frame so that we can store all of our data. And then with the so we need to actually create this first, ensemble of ensemble. The first one that we have is decision tree. We call it tree classifier, I believe we call it decision tree. Yep, tree classifier. And data frame, we're gonna store our prediction in here. So we have the tree classifier and predict the prediction, and we're going to use the not the prediction, the probability. Okay, we're going to build our model, remember, so it's still that one. Now just so that you can actually see what this is, so we have printed that. So we're only interested in the so-called first column. Why is that? Okay, so let me just bring up this for you so that you can actually, sorry, the first column, not the zero column. So let me just print that out. What you have here is that the output returns an array of sample. You have the n samples, you have the n class, or list of n outputs. Okay, such arrays if the n outputs is greater than 1. So we don't really want the n samples, we just want the n class. Okay. Okay, so remember we only want the column 1. Okay, so that's the actual probability itself, or the prediction itself. So ensemble of ensemble, what we want next is our random forest classifier. It's the same as this, except that we want to use the classifiers RF, COF. Okay, having done all that, the column names, we're just going to call it ensemble. We're just going to extract it from the ensemble. Now let's see, ensemble columns. We have the columns, which is from our original data itself. Okay. Okay, so let's just store our column names. We're going to need that later. I'll show you later. And our final ensemble is equal to the concatenation. Ensemble, and the data frame of our Y train. And what we want to do next is and drop is equal to true. Okay, and the last thing that we want to do is the axis is equal to 1. Okay, so we have the ensemble. Let's have a look. So this is what it looks like. Okay, this is our output data. So the last one here is actually the Y train. Okay, the Y train data that's being inserted here. And then we have the prediction of both of the tree and also the random forest. We're actually creating basically a data frame here, so that right now we're gonna prepare these to utilize this for our next model, our classifier, to see all of these two, which one to use, so that and going forward. I'm just gonna store the column names and convert it to a list first, and we're gonna append the indicator, and ensemble of ensemble columns is now gonna be TMP. Okay, right, that's all prepped now. So if we look at the whole data frame itself, this is what it looks like. We've got everything sorted. Okay, so remember, we are working on combination. Okay, so let's just come back here. We're looking at ensembles with different types of classifier. So we have different type of classifier. So far we use decision tree and random forest. Of course they are small, but for now this is sufficient. And we're going to combine them using another classifier on top of it. So we're going to have a meta classifier. I think just for the simplicity's sake, we're just going to use logistic regression. Nope, we have not imported. So from scikit-learn, and from the linear model, we're going to import logistic regression. Okay, so and let's instantiate this. I think for now we don't have an intercept. And the next thing is that we want to fit our classifier with the ensemble of ensemble, and we're going to just select the tree classifier as well as the random forest classifier. Okay, so that's our X train, and the Y train is ensemble of ensemble, and we're going to use the int. Okay, so that's fitted. Right, having done all that, okay, so the next step now really is that we want to actually look at how well does it actually perform out of sample in our test data. So we're now looking at the actual test itself. We're going to repeat the exercise that we did earlier, which is this one here. Okay, so we could just copy this. So we have a tree, and we have the random forest, except now it's no longer the train. We're looking at X test data. And we're gonna combine them all, and so instead of that we call this test, we'll call this test, and we'll call this test, and we are going to combine them all and call them combined. I'll just call this combined, it's a lot easier. And finally we have the classifier, and we're gonna run a prediction. And how does this work? It's basically a combination of the two and tree classifier as well as the random forest classifier. So we're actually combining the two together and basically combine. Okay, so we call it combine. Right, again we have the same thing, which is the column name is equal to the ensemble test columns. And we're gonna append again, so the list of the column names, so that and then append ind. Okay, so let's look at this. So we have the 2 plus the this actually shouldn't be combined, so that's better. Okay, having done all of that, now let's look at the ensemble test. And I'm going to concatenate the ensemble test with what? With the test. Y test. Again, we're going to reset the index. We're going to drop the index itself. True. And finally, this should be axis is equal to 1. Okay, so ensemble test columns is, I'll just rename it as TMP. Okay, so now let's time to print the actual performance of our ensemble. So let's have a look at how well it performed out of sample. So what do you see? You can see that this is actually the confusion matrix. So it scored 262 correctly, 19 correctly, and these 239 plus 48 incorrectly. So let's calculate the actual accuracy itself. So we're just gonna print the accuracy, which is, let's just round this accuracy score of the ensemble test, the indicator versus the ensemble test of combined, and we want to round this to 4 decimal places. Oh, it tells us that it's 100%. So let's just close this and see. Well, it tells us that it is actually 100% accurate, which is pretty interesting. Well, probably shouldn't have rounded like that. So it's actually 76%. So we should really round this properly. I think this is inside here. Nope. Just call it 4. Nope. Why doesn't it do that properly? Ah, that's better. Wrong place. Sorry about that. So what you see is that the accuracy score is 76%. The last one that we want to actually check out is the actual classification report. And again, these are exactly the same. So we're just going to copy this. Alright, so this is the actual classification report. We see a similar problem as we did in the past, the precision and also the recall score for the minor class, because of the disproportionate nature of the class itself. What we do see now is that the it's still repeat. The problem hasn't gone away. Although what we have done here is that, as you can see, we've managed to actually combine 2 models together to improve upon. Have we improved? So let's look at 76 is our accuracy here, or the prediction accuracy. If we look at the on their own, 76 for random forest, 76 for decision tree. So this is the tree classifier, and this is our random forest. Well, we did the same thing, didn't we? I'm sorry. So just change it to RF. 86. Well, it seems like the accuracy has gone down rather than gone up. Well, it's unfortunate. Okay, looks like what we need to do is actually to maybe possibly do further tuning. That's one. The other thing is that looks like we need to actually tidy up, add more classifier to improve upon model. It could be that the meta classifier is not suitable for this, but nevertheless, what you can see here with this model is that it's necessary for us to actually do a bit of tuning, but ultimately the purpose of this exercise really is to show you that it can be done. What I'd like you to do now is to add one more. I encourage you to actually, on top of decision tree and random forest, try to add one more. It could be add a boost. It could be logistic regression. So give that a go. Pause the video now, and when you come back, I'll wrap up the lesson. How did that go? I really hope that you've given that a try, and I know it's probably quite challenging because there are quite a lot of data munging and data tidying up to actually have it fit into a combining all of the different series together. Nevertheless, I think you probably understand the actual whole process flow now, and I hope that you found it useful. and thank you for watching.